Okay, here is we're going to find the limit using the epsilon delta definition to prove that the limit is L. So in doing so, what we have is this function. This is a parabola. Parabola is once again continuous. And what we're going to do is we're going to first find the limit of L for this particular limit equation. So as we approach -3 from the right and left side, since this is continuous, we know that the value of the function and the limit will equal the same thing. So that means when I plug in -3 into here, all right, that will give us our limit. So we have 9, all right, and that's going to turn into minus 9, okay, and then we have 0. All right, so our limit is going to equal 0. All right, our limit is equal to 0. Cool. So here's our limit, and we want to figure out, okay, what is the epsilon delta definition? What is an epsilon? What is a delta that will guarantee us that we will be able to approach 0 from the right and left side? So using epsilon delta, we have, first off, a delta, which is going to be greater than 0. All right, this is going to be our input. So this has to be x minus c. Now our c value is going to be -3, so we're going to have plus 3 here, which is going to be less than delta. We're also going to have an epsilon, all right, which is going to be greater than 0. Okay, and this is going to have a value where we're going to have our function, which is x squared plus 3x, minus our limit, and our limit is going to be 0 in this case, which is going to be less than epsilon. Now, our goal here is we're going to be taking this, and we have x squared plus 3x, and we are going to take this and we want to make this inequality resemble this inequality right here. Well, in doing so, what we're going to do is we're going to take this function, and you realize that we can actually divide by an x. We can factor out an x here. And when we do that, we have is x plus 3. Now, in many of these other problems, our goal is to make this inequality, all right, same as this inequality. So the only thing that we're missing is we have this extra x. So what we're going to do is we're going to take this value right here, and we're going to divide epsilon by x. Okay, divide by x. Now, the question is what x are we going to be plugging in there to help us get us a proper epsilon? Now, in doing so, what we have is we have -3 right here, and we're trying to find a fraction that will allow us to find this value. Now, what you have is we are dividing by this x. Now, this x has to be an absolute value as well. And now from here, this is where it can get a little confusing, or at least for many students, including myself at times. All right, when you're doing this, now what is x going to be? Because we need to find a value. Well, epsilon right here, absolute value of x, we're going to have two different values that we can plug in there. Okay, because we are on this interval, if you think about this, x, our c value is at -3. Just to make this easy, we're going to pick two values to the right and left of -3. So right here we're going to have -4, all right, just pick integers, simple integers, and we have -2. And what we're going to do is we're going to take these two endpoints, all right, which are to the left and right of -3, this is our c value, and we're going to plug them in for x, because remember, x is approaching c, and that's why we're taking these two values, all right, those integers to the right and left. Now, we're going to just use those because they're the easiest ones to work with. All right, we can pick smaller increments. All right, but we're just going to pick those because they are simple. And now we're going to plug these -4 and -2 in for this absolute value of x that we factored out and we divided to the other side. When doing so, we want to pick the lesser of the two values. So if you compare, all right, the absolute value of -4 compared to the absolute value of -2, which one is going to be greater? Well, e divided by 2 is going to be greater than e divided by 4. Okay? And because this one is the lesser of the two evils, we're going to take, not necessarily evil, but we're going to take those and we're going to plug that in there. So we have epsilon, all right, is divided by 4. Okay? Now, here, we have now found a epsilon, or actually our delta. Because delta we can now say, because we got these two equal each other, delta then is going to equal epsilon divided by 4. Epsilon delta divided by 4. So now, as we go through, if you wanted to continue to prove this, we can now write this out, epsilon divided by 4, which is less than x plus 3, all right there. And how do we get that? That is going to be less than epsilon of the absolute value of x, all right, like so, all right, which has to be less than 0. And as we go and solve this, we basically are just going to rewrite this expression, all right, making sure that this all works out. If we multiply both sides by x, we'll have x inside here, plus 3, epsilon. We have x squared plus 3x. And so using this, we just went backwards, all right, and once again, reproved that, yes, this, when we have delta, using that, does get back to our limit definition, which is f of x minus L, which is less than epsilon. This is f of x, L is 0, and we have our answer. So, long story short, how do we get and find delta? Using the same methods. We set up our epsilon, we write this out, we find out where do we have x plus 3, right here. We have to divide by x. This x value that we have, we need to plug in the values. How do we pick what values to plug in? We'll look at the c value. Look at the c value. Our c value right here, all right, is -3. We pick two integers to the right and left of that. We compare those two integers when we plug it into these values right here, okay, into this value. We realize that when we plug the -4, the absolute value of that is going to be less than the absolute value of -2. And there, we're going to put that in here. Once we have this, we realize that, okay, now we can figure out delta is going to be equal to epsilon divided by 4, because these two inequalities are very similar. To prove that, we can continue on and work backwards and reprove it by getting back to our original function that we started out right there. And that is the epsilon delta definition of a limit. Okay? Key thing, once again, writing out your two major forms, this one and this one, all right? And then solving for delta by getting epsilon by itself and where the inequalities are equal. All right? Well, hopefully that was some use to you, and then hopefully that will allow you to do some more complex problems as this one right here. All right. Good luck and God bless. Oops, wrong one.